Welcome back to the channel. Last video we did a couple of examples of arc length when we already knew the circumference of the circle. Now remember, circumference is that distance all the way around the circle. Okay, so and in the last video where we talked about pi, we learned that pi is the ratio between the diameter and the circumference of a circle. So we learned that circumference is equal to pi times the diameter. And again, I'm going to drop a link right now. You can prove this to yourself within a certain degree of accuracy on your own using items that you can find around the house. Another way that we often see this is circumference equals 2 pi r. And that's the same thing. Diameter is the same thing as 2 times the radius, right? So no worries there. These are two equations that say the same thing. You're going to see 2 pi r more often because generally we care more about the radius than the diameter. And just in case you don't remember from IM1, the area of a whole circle is pi times the radius squared, pi r squared. So I'm going to give you a few seconds, pause the video, write these formulas down if you need them, because we're going to be using them in just a moment. Okay, here we have two arcs and we want to find the length of each arc. Okay, so in problem number 1, we have a circle that has a radius of 11 feet. And we are looking for the length of this large arc all the way around, which has an internal measure of 315 degrees. So again, remember from previous videos that arc length is the ratio times the circumference. And in this case, we don't have either of those things yet. But I think you remember how to find the ratio. We have a 315 degree angle, and that is out of a total of 360 degrees in a circle. And we'll reduce that in a minute. And then the circumference, well, if we go back to the notes we literally just took, the circumference is either pi times the diameter or 2 times pi times the radius. Those are both the same equation. So our radius is 11. So our circumference is going to be 22 times pi. And again, since we're dealing with fractions, I'm going to put that over 1. Hey Google, reduce 315 over 360.
Here's a summary from answers. Reduce 315 360ths to lowest terms. Find the GCD of numerator and denominator. 315 divided by 45,360 divided by 45. And reduced fraction, 78.
So the audio didn't do a very good job of reading that, but the reduced fraction is 7 over 8. So 315 and 360 are both divisible by 45, and it becomes 7 over 8 times 22 pi over 1. Let's see, I think there's a little bit more canceling we can do here. 8 and 22 are both even, so I can divide them both by 2. I believe my final answer is 77 pi divided by 4. And again, I could use a calculator to come up with a decimal approximation if I wanted to, but I don't want to. I'm going to leave it like this. Let's look at another one. Here we have 270 degrees as my central angle. I'm still looking for the larger of the two possible arcs. And I know that my radius is 13 feet. Take a moment, pause the video, see if you can find out what the length of this highlighted arc is. Well, okay. Let's take a look. Now, normally I would go 270 over 360, right? But if you actually just look at the problem, if that's 270, then this other angle here is just 90. So that ends up being 3/4 of the circle. And again, if I was to reduce 270 over 360, I would get 3/4. So there's our ratio. We are looking for 3/4 of the circle. So now we just need to know how much the total circle is, which is going to be, let's see, 13 times 2 for the diameter is 26. So it's going to be 26 pi over 1. Let's see, 4 on the bottom, 26 on the top. Those can cancel. So we get 13 on the top and 2 on the bottom. It looks like we get 39 pi over 2. Now these problems are a little bit different. Instead of finding the arc length, it's asking us to find the area of each sector. So we're not looking for just a length now. Now we're looking for an area. Round your answers to the nearest tenth. So in this case, we are going to get a decimal, and we'll round to the nearest tenth. All right, so let's look at number 13 on this worksheet, which again, I will link in the comments or in the description. So here is the wedge that we're looking to take the area of. We don't want the area of the whole circle. We just want the area of that one highlighted wedge. But this is going to work exactly the same as finding arc length. When we found arc length, we took the ratio, the fraction of a circle that we had, and we multiplied it by the circumference in order to get what the arc length was. With area, it's exactly the same, except you're going to take the ratio and you're going to multiply it by the area. We still have some fraction of a circle. We're still going to take the total area and divide it by, or multiply it by that fraction. So in this case, the ratio finding is still exactly the same. We have 60 degrees out of a total of 360 degrees. And now we have to multiply that by the area. Now remember, area is pi times the radius squared. Pi times 10 squared. Okay? Well, now let's do some simplification. We found out in an earlier video that 60 over 360 is the same thing as 1 over 6. Try it yourself if you don't believe me. They're both divisible by 60. 10 squared is 100, so we get 100 times pi, again over 1 because I'm dealing with fractions. Both of these numbers are even, so I can get 50 on the top and 3 on the bottom. I get 50 pi over 3. But, again, the problem says round to the nearest tenth. Hey Google, what's 50 times pi divided by 3?
The answer is approximately 52.359878.
52.4 to the nearest tenth. Inches squared. So if you can find the area of a circle, you can find the area of a sector. if you can find the circumference of the circle, you can find the length of an arc. It just involves a little bit of division and a little bit of multiplication. We're going to do one more and then we're out of here. Number 14. Here we are looking for the area of this sector with this 150-degree central angle. So let's see how fast we can do this. We have 150 degrees out of a total of 360 possible, or total. The area is pi times the radius, which is 3, squared. I put it over 1 because we're dealing with fractions. Let's see, 150 over 36. They're both divisible by 10, which gives us 15 over 36. 15 and 36 are both divisible by 3, so we'll make that 5 over 12, and I think that's as far as we can go. Okay, so we get 5 over 12 times, let's see, 3 squared is 9, so 9 pi over 1. We have a little bit more simplifying to do. 12 and 9 are both divisible by 3, so we get 3 on the top and 4 on the bottom. So we get 15 pi over 4. Hey Google, what's 15 times pi divided by 4?
The answer is approximately 11.780972.
So rounding that off, we get area is approximately 11.8 square meters. That's really all there is to these. Once again, if you have any questions, please do feel free to let me know what they are. You can send them to my email, you can put them in the comments, you can write them on Google Classroom. Pretty much anywhere that you post them, I will see them and I will respond to them. Thanks very much for watching. I'll see you tomorrow.